So before we go into a few practice problems, I first wanted to go through the Biot-Savart law, like a different version of the Biot-Savart law, in case you have moving charges. So we can modify the Biot-Savart law equation to be written in terms of charge density, or not charge density, charge and velocity. So then this would be useful for moving charges at a certain speed. So how do we change the equation? Let's first start off with our definition of the Biot-Savart law. So dB is equal to mu naught over 4 pi I dl crossed with r over r squared. But is there another way to represent our current? When we talk about current, we're actually talking about the charge that moves per unit of time. So that means it's going to be some sort of change in charge over some change in time, because current is charge. Per unit time. So let's replace our I with this definition. It means we have dq over, let's just put this here, dq over dt, then we have dl crossed with r over r squared. So what else can we do? I want to be able to represent this as charge and velocity. Seems like I already have charge over here, and now my velocity needs to be defined as something else. So I can define velocity as I take a look at the differential elements here, which can be rearranged. If I'm talking about velocity, I have to move a certain distance per unit of time. So the only thing that makes sense from this is my dl. So I'm moving a certain distance over the length of a wire that carries some current over time. So that means I can kind of group these together and combine that to become V. And so I have dB is equal to mu naught dq, and then I have V crossed with r over 4 pi r squared. So that is the Biot-Savart law for moving charges. And so now we have two different versions of the Biot-Savart law that we can use for different scenarios. Pick the one that is most suitable for the question, and then move forward to calculating your magnetic field.